our next part of our program is a bit different. We'll try and be a little bit interactive. We have a pair of community discussions that are going to be moderated by Lawrence. First, we'll talk about virtualized applications in BOINC. So we'll turn it over initially to Lawrence. Let's make sure he's unmuted. And he'll ask some questions, use the hand raise to participate. What we'll do is when you're done answering a question, we won't mute you right away. And please don't mute yourself after you answer too quickly, because we want to allow for a little bit of back and forth, and we don't want the friction that would be entailed with having to click somebody every single time in an exchange. So all of that said, it's our first experiment with a larger group discussion. We'll turn it over to Lawrence, and I look forward to learning about from everybody what's working initially with VirtualBox applications, what people's challenges are as projects, as users, but I'll let Lawrence guide the discussion.
Okay, thank you. So in about 10 years ago, LHC at Home experimented with virtualized applications. So this was after the success of the 6-track project, and I think that this started in around about 2006, I believe. Sorry, 2004. So in 2011, we decided to try to enable other applications that weren't. So the main challenge was being able to port to Windows, and these software frameworks are very big, quite complicated, and it's amazing sometimes that they even get written once, let alone in such a way where you can port them to multiple platforms. And also there's a lot of, let's say, glue that holds them together, like Bash scripts, Python scripts that may not just run out of the box on another platform. So the solution to this problem was to try virtualized apps. And this is where the VBox wrapper, which we heard about, came from. And this has progressed to become let's say a core part of BOINC, or a mainstream part of BOINC, and many other projects are using this. So we personally have had some success with this. We have 3 projects that are using virtual machines, but it also comes back with, sorry, it also comes with some additional challenges. So of course you have to package up the application in such a way where it works. And also we find that we lose a lot of volunteer capacity. So maybe with a native app, we get 100,000 running jobs, but with the virtualized apps, we get maybe 10,000. So we're losing capacity, and also due to the additional complexity, there's more, let's say, failure modes that can occur. And we have spent some effort to try to resolve these over the years. And I think we have made some progress. And as you saw from the presentation from Stefan, there's always improvements that can be done. But more recently, we've been looking at containers, mainly on Linux, as a way to encapsulate the software without the need to do virtualization. But of course, on Windows, you still need the virtualization layer to enable the containers to work. So I'm interested to know, kind of, first of all, from the projects that have used VMs and the VBox wrapper, what their experiences were like, what were the problems they found, what went well, what didn't go well. So I open the floor to feedback and complaints.
Yeah, let me interject briefly one thing for everyone. I find for these exchanges, it's quite useful to switch your Zoom, which offers multiple view modes, to speaker mode. And that way, whoever is talking will automatically get the spotlight in your screen. So if you're, I don't know how much the different platform implementations of Zoom vary. On my Mac, the view button is just underneath the application bar in the upper right. And if you click on it, it gives you a few options. And again, I'd recommend speaker view. So with that, I'll echo Lawrence's call for anyone from any project who's running VirtualBox to share a bit about how that's been going, what the challenges are, and see what we can learn from each other. So any questions on that topic? We had Stefan, who of course just gave us a very nice talk about one of the challenges being user experience issues related to startup times and disk I/O, which he addressed with his work. Does anybody else have anything that they want to share? David, do you have any thoughts about what you're hearing from people running VirtualBox apps and what you're thinking about in terms of challenges current and fixes future?
Well, I wish that Rosetta were here, because I think that they're, as was pointed out, they released a virtual app with a huge image, and that caused a lot of problems for people. It would be nice to figure out some way to get virtualization without requiring people to install VirtualBox. And we might want to, in the future, look at other virtualization technologies.
Okay. Lawrence, any other thoughts?
Yeah, so I mean, moving on from the virtualization, I know that there's a number of other possibilities for achieving similar kind of things. For example, containers, which hopefully will become more common in the operating systems. Does anybody have any thoughts on other alternatives for other than using the virtualization?
My impression, and I don't know because I haven't looked recently, was that Docker for Windows was not so great. That likely not a permanent state of affairs, and maybe even isn't true anymore. Does anybody have any experience with that? Eric is mentioning Singularity. That's another containerization platform or technology, I think. So similar to Docker.
Yeah, so I think that Singularity is an alternative or is a container, but again, it comes down to how do you get the containers running on the different operating system. And I'm not too sure about the Docker on Windows, but Linux containers on Windows is something that I think that they have tried. I'm not familiar with the current state of the art. Does anybody have any thoughts on containers on Windows and where that's heading?
No.
Yeah, Andy mentioned WSL, which would eliminate the need for VirtualBox, but my understanding is that WSL is not enabled on Windows by default. I also want, let me just interject that I think WebAssembly is something we should think about. It's not exactly virtualization, but it eliminates processor and operating system dependencies.
Yeah, I agree. I think one of the challenges with WebAssembly is going to be similar to the original problem of having to port the code to something like that. So it may be possible for some applications, but not possible for everything. Do you know if there's any projects that are looking at WebAssembly?
I haven't looked at it. Does anybody have any experience?
I think there's also a concern about performance with that too. I'm not so sure you're going to get native performance. I mean, the issues with Windows is that I think that the Docker container engine is using something like WSL underneath to provide a sort of a base Linux-like abstraction layer, so the containers actually see what they expect to see, because almost all the containers that are built to run on Docker are expecting a Linux-like environment to run in. And Windows without you can do it through WSL, but then WSL has its own limits, and it's kind of difficult to use for a lot of people. And as was pointed out earlier, it's not installed by default. Right. So none of the only virtualization technology that's installed by default on Microsoft platforms is hypervisor, is their own whatever their own hypervisor solution is, Hyper-V, right? So, and that thing is Microsoft centric and is not portable to any other operating system. So you're sort of stuck, if you're going to straddle two worlds, you either have to pick a virtualization technology that works across the board, or you're going to be forced with rolling out multiple versions of virtual machines, which sort of blows up the whole idea, right? That using the single code base to go across all platforms. So it's kind of it's an ugly situation. You've got Linux users that are very powerful and run a lot of machines, and they tend to be overweight in terms of the count of like CPIDs versus the number of the actual horsepower generated. But then there are lots of Windows users that are, more maybe laissez-faire, but there are lots of them. And if you leave them out in the cold, you're leaving out a significant amount of computational capability. So I think the situation remains pretty ugly in this area.
Yeah, sorry, go ahead.
I was going to say we have Eric with his hand up for a while. Eric, I think you're unmuted.
Yeah, hi, I hope you can hear me.
Yeah.
I'm just as a user, I'm using VirtualBox version 7 something or other on Windows 10 and Windows 11. The virtualization, I was seeing virtual machines pop up pretty often a few months ago, but then it just stopped. And I don't know if this is due to some configuration change I might have made, or if the projects I'm subscribed to stopped doing it or something else. I've tried looking at BOINC documentation on VirtualBox, and I haven't really found anything that's been able to help yet. Does anyone else see this? Are there?
Yeah, I have. Well, for one thing, Rosetta went back to, it looks like, to a native app. So if you're running Rosetta, it looks like they're back to using a native application. At least that's what I've been seeing. So I think that there's been some movement of projects away from the virtualized containers back to native applications, which may explain some of it. I've got 7 too, and I haven't seen a single virtual machine type task come over in a while either. But
no, I also get warnings in the BOINC stats GUI saying that virtual, I can't remember the right word, but virtualization is not enabled. In the meantime, I'm running VirtualBox with some VMs in it, independent of BOINC. So I'm not sure what's going on with that either.
Vitaly was asking folks to report on the BOINC Discord server, the compatibility with BOINC 7, with VirtualBox 7 Plus with BOINC. I don't know if, a formal determination was made whether there's a big compatibility issue or not. So I don't know if Vitaly wants to comment on that, but.
Okay, well, thank you.
Yeah, there was this there's this notion of like VM extensions, that kind of instruction set capabilities that need to be turned on to efficiently run VMs. And I think on some machines, you had to go into your BIOS and turn these things on. And you know, BOINC has some logic that tries to figure out whether these settings are turned on or not. And I'm not really sure that logic works. I mean, you may be in a situation where BOINC thinks that you can't run VMs when you actually can.
Yep.
So we should figure that one out.
You've got that one, and there's also the VirtualBox extension pack that I don't know whether any of those VMs require like the special extension pack for additional capabilities. That also is not installed by default in VirtualBox, and it's something else that people have to go and install. I know I've had used that for other virtual machine applications on VBox. I don't know whether BOINC requires. It's just a lot. You know, David. You know what it is? It's just a lot of futziness, right? It's most Windows users want to point and click and install, and they don't really want to. Linux users are a different ilk, right? I mean, when you're a Linux user, you're used to having to muck around with the machine to get things to work most of the time. I mean, the Linux users Windows users is different, and they get very frustrated if things, you know, don't work out of the box, and you know, so it's a different break point for those folks. And Windows does seem to be more brittle in these areas. And that BIOS setting you're talking about absolutely is the virtualized instruction set. A lot of consumer machines have that turned off, so they won't actually run the virtual instruction set. So that's another impediment. Most people have never been in their BIOS settings and probably wouldn't know how to get there, even if they you said to them to go do that. So it's tough.
Yeah, I'm a retired IT engineer, worked on HPC Linux systems, so I'm used to digging around. I extension pack, and I'm dinking around in Windows trying to figure it out. Like I say, I changed the BIOS. I can run virtual machines in VirtualBox on a Windows machine. So as far as I can tell, it's either BOINC's a little screwy somehow, or projects are not submitting virtual machine type jobs to me anymore. It's good to know that other people are seeing this too.
So one of the things you could check to see if it's working is to connect to LHC at home. Sorry for advertising, but there are the theory project that we have is fairly lightweight and always has work. So if you would like to test whether virtualization is working, this is a good project to test.
Yeah, subscribe to LHC at home, and I don't see, like, I've been watching my tasks, and I haven't seen anything from LHC in a while, so I don't know what's good. Maybe I need to unsubscribe and resubscribe, something like that.
Yeah. Maybe
Yeah.
I can.
Eric, if you're seeing messages about can't run VM apps, there's probably this issue with the CPU capabilities. So I don't know if you're on GitHub, but you might want to create a GitHub issue, and
Okay.
then we could work with you to try to debug things.
Cool. Okay. Sounds good. Thanks.
Sounded like Roland had a question.
Well, not so much a question, more I want to underline, support what Eric has said. My experience as a user for VirtualBox has been that simply it's too complicated. Several times I've had issues where I set up the VirtualBox and it worked for me, and then after a month, 2 months, it would stop, and I would try to troubleshoot myself and reinstall, resubscribe, and maybe 2 or 3 times. This helped me to get work again in BOINC on the virtual machine. But then after a month or 2 months, it would be the same, and then I would troubleshoot. And at some point, I came to the point where using the forums, I was troubleshooting, and I was having to go into my BIOS settings indeed, and I didn't know what settings I was changing exactly. So then I just decided to stop using the VirtualBox basically. This is also as a Windows 10 user. So yes, I agree with the notion that if you want to get the Windows users on board, it has to be a little bit more user-friendly, because I don't consider myself to be I consider myself to be a better than average computer user, but it still came to the point that it was too complex for me to solve.
Okay, thank you. Oliver notes from Einstein at Home that in chat that this is an argument in favor of where possible, potentially making development efforts to port an app. Now, not every project will have that option for a variety of reasons. And Byrne notes also that with VirtualBox anyway, you can't access GPUs from the VM. Dave had his hand up.
Yeah, just a quick thing. Using VirtualBox on an Ubuntu system, I found that I had to change in the system, in a system file, client protect equals strict to client protect equals full. Otherwise, nothing works, everything crashed. And it was very difficult for me to find where to do, the instructions to do that.
Okay. Documentation then may be an issue that we can look at as well.
In the client.service file, where that had to be changed.
Okay. So with that, we could probably go on quite some time.
Can I make one other little comment, Matt?
Sure, yeah.
Well, all this stuff is kind of restricted to Intel architecture. And the world is, I think, long-term moving to ARM. And that's kind of an argument in favor of WebAssembly, which would work anywhere. And I haven't used WebAssembly, but I mean, in theory, you can compile C++ programs for it. And its champions say that it runs at pretty much the same speed as, GCC compiled code.
What about QEMU that Andy mentioned earlier? Is that an alternative?
Well, that still doesn't solve the CPU architecture issue.
Yes, QEMU, when you're running an Intel QEMU style virtual machine, uses the underlying Intel virtualization layer, so it's like 90% Intel speed, but it's using pure emulation for ARM. So ARM is much slower, maybe 1/10 it's 1/10 the native speed of an Intel processor. It might equal a reasonably fast ARM chip, but you're not going to get anywhere near like M1 level performance from a QEMU ARM emulator, at least running on an Intel chip, because it has to convert all the instruction sets. So David, I imagine we'll probably also see native virtual machines for very powerful ARM chips too, right? That are running native, essentially native virtualization rather than instruction translation. And I would assume those would run at near full speed, just like the Intel virtual machines do. So
yeah,
I don't think we've seen any of that in the wild though.
Okay, well, hope people found that interesting. There's definitely more to come on that in the coming months and years. So let's turn over, at least briefly, to have a similar conversation about GPUs. So I'll turn back the floor to Lawrence to kickstart a similar, just a community assessment of a report on GPUs.
Okay, thank you. So as you saw from one of the early presentations, LHC at home is starting to go down the GPU route. I know that we've been quite late to the game in this, and other projects, for example, like Einstein at home, have been doing this for many years and have a lot of experience. But I think that, as David mentioned, that, you know, the future is maybe ARM processors, but I think we're going down more of a road of heterogeneity. So whereas I think the world of just the x86 processors and C++ was where most of the software was, I think that in the future it's going to be a lot more diverse. And GPUs is, of course, one way to get more computing. There's a lot of GPU-enabled devices out there, but it's and it's something that a lot of our volunteers have been asking for, because we didn't have an application that could use their GPU. So going over to some of the projects that have had a lot of experience, I mean, what are your thoughts on using GPUs? What are the pitfalls, and what do you have any suggestions for us?
Yeah, so if I may, Oliver from Einstein Home. Yeah, pitfalls. And I mean, we started out doing the GPU development in, I think, 2008 already, and have been doing so since then. And we've used an, say, iterative approach. We started out using NVIDIA's CUDA framework, first of all. And there we started out simply using or replacing the FFT library we were using at the time on CPUs, where we were developing the GPU application where we simply ran a part of the algorithm that we implemented using the CUDA libFFT library. So because our search at the time, the one we picked first, depended heavily on FFTs, like many scientific applications do. So that was a low-hanging fruit to get our feet wet. So that's how we started out. And then over time, we delved into the whole topic a bit deeper and then started developing our own CUDA kernels, as they are called. So the actual programs, custom programs that run on the GPU. And so iteratively, we developed those kernels, and over time, more or less could port the whole algorithm that makes up our analysis software over to the GPU. And with each step, obviously increasing the efficiency of the program. So using less and less CPU power and more GPU power in contrast. So that's the approach we took. And from that experience, we moved over to all the other different applications we have and looked into those as well. So going step by step is probably one of the important things, I guess, you should follow, or everyone should follow. So there's maybe one thing that's the biggest concern here, and that's numerical stability. Yeah. So if you have a GPU application and a CPU application, you want to validate the results against each other. That's a tricky thing, because mathematics or the math implementations on CPUs and GPUs can vary widely. It really depends on the configuration. It depends on your algorithms and on a number of factors. So the comparability of results for cross-validation, that's definitely a challenge. And then, yeah, sure. Other things are, for example, if you want to support more than NVIDIA GPUs, you have to consider OpenCL, of course, which is a total different beast. Yeah, there are similar libraries like that allow you to replace or run FFTs on OpenCL or AMD GPUs for that matter. But providing or writing those kernels for AMD GPUs, for instance, is a different thing because they have a different hardware architecture. So if you really are after the ultimate performance, you have to take care of the underlying hardware if you want or not. So that can become a challenge, obviously. And another thing for us was to provide all those GPU applications across all the operating systems we support. That multiplies the the complexity, of course, because we do support Linux, Windows, and macOS on NVIDIA, Intel, and AMD GPUs. And what we do is, so yeah, there you already see the permutations going on. And all of those have to be stable in terms of numerical calculations across everything, ideally, if you can hold that up. And that's always been an issue. Likewise, you have to pay attention to what kind of GPUs you require from your volunteers. So what's the threshold to enter? What kind of GPU does the volunteer have to have in order to run your application in terms of computing power, in terms of memory requirements, especially. And we always have to, or we always try to, lower the bar as much as possible in terms of RAM requirements, for instance, such that the population of GPUs available to us can be maximized. Yeah, so that's always something we strive for, such that everyone can participate, basically. So in terms of driver versions you require, I think currently we are running CUDA 5, if I remember correctly, or CUDA 10 in a special version. So we are not requiring the latest and greatest CUDA versions and compatibility levels and what have you. So that's also another thing to consider, I think. And yeah, maybe one last word concerning CUDA. We opted to use the CUDA driver API. That's a low-level API and not the standard CUDA implementation running their libraries. That allowed us to have much more fine-grained control over the compilation process. And also, most people won't know that, but for deployment in our native environment, we are even cross-compiling our Windows applications on Linux machines using the CUDA driver API, which is only possible using the driver API. So that's a matter for our build farm that allows us to facilitate the building, I think, up to 19 different binaries we currently run natively on Einstein at home. So that's possible, but that's a niche case. So I don't want to talk on that too much. And I think I've consumed quite a lot of time already. So if you have any questions, let me know.
I have a quick question. You mentioned how you try and keep the memory down such that you have the largest possible pool of devices that could run the app. What's your sense about what portion of the memory on a GPU you can use on a volunteer device before it creates headaches for the user's other activities?
Well, I would argue that our applications you don't want to use on the GPU you're using to render your desktop. It should always be a separate one, because our applications are so efficient nowadays that they basically consume the whole GPU if you let it, right? So that means if you run the application on the GPU that renders your desktop, you will notice it because it's going to be stuttering like hell. It won't work effectively, I would say. So this is just every volunteer, from my point of view, running our applications should run such an application only if there is a spare, separate, dedicated GPU only for computing available.
Hey, Oliver, that's highly hardware dependent though. So for example,
sure, yes, it is.
Right now I'm actually doing an Einstein at home GPU work unit while I'm on this conference call and on the desktop. But I have a really powerful machine and I have a 4080.
Which application are you running, if I may ask?
Let's go see.
Because they are different in their relative efficiency and GPU usage.
Let me see. Just give me a second. Multi-directional gravitation.
Okay. Mm-hmm.
Yeah.
Thanks.
Yeah.
Yeah. Okay. Again, so we do have the, as I said before in the chat, we do have different applications and different efficiencies that have different requirements. And also in the plan classes we use to control the different app deployments across computers, the different efficiencies are taken into account. And volunteers also do have the possibility to set the amount of GPU they want to assign to our applications using our website and the user preferences. So they have control over that. However, that's a pro feature, I would say, that I don't expect everyone to deal with, because most people might not even know about it. That's for really the hardcore crunchers.
Yeah, I think there's one other comment too I'd like to make in this area. You're right, for most computers, and I have most users are going to want to pause the GPU when they're using the console.
Right.
And you know, we've had consistent issues with believe it or not, this is where on the Linux side it's more iffy. The idle detection doesn't work properly, or hasn't worked properly for a long time on most Linux installations. And it has to do with a combination of different things, including security settings and a whole bunch of other things. That's one area where Windows seems to work better, is automatically pausing the GPU when you start moving your mouse around or whatever. So I think, you know, this is another area which causes people irritation, where, you know, they have to manually pause the BOINC to actually make their console reasonably responsive, right? A lot of people just want to have it automatically pause, and that has not worked as reliably as we would like it to. So we get a lot of complaints about that.
And just another FYI in a similar thing, what we are not doing for GPU applications is we don't ship any screensaver with it. So we do have a nice fancy screensaver that people like so much, but for the GPU applications, nope, we're not shipping it because it's detrimental to what we're trying to do, right?
Yep.
David, you had your hand up.
Yeah, so the default preferences, as I think you know, are to only use the GPU when the computer is not in use, and that, you know, that works fine on Mac and Windows. I think we should be able to solve this problem of idle detection on Linux. I mean, the problem is that there's so many variants and, you know, X server configurations and stuff like that. But I think that that can be figured out. The other thing I wanted to kind of propose is that a lot of computers, like the laptop I'm on right now, have an on-chip Intel GPU and a separate NVIDIA GPU, and you can configure the system to use one or the other to do your actual screen graphics. And it would be sort of interesting if we could figure out how to make it so that BOINC uses the GPU that is not being used for graphics to do computing, maybe even while you're using the computer.
Yeah, that's a really good idea.
I don't really know how BOINC can find out which GPU is being used to do graphics.
Yeah, that's a good idea, David. And some desktops have that capability too. You have an Intel CPU that's installed that has its own GPU, but then they may have a discrete GPU that they installed. I think the default is that the built-in GPU on the processor is disabled, but I think there's a way to actually make them both work at the same time. That's an interesting, I think it's not only for laptops, but there might be people interested in that for workstations too. Quite interesting, yeah.
Any other thoughts from projects running or thinking about running GPU apps, about issues or concerns or complexities or anything like that?
I have one more, Matt, on that. I think someone mentioned that you can limit the number of CUDA cores that are used by an application. That could be an alternative, capping like to 3/4 of the number of CUDA cores, which it would be akin to like on the CPU side saying I'm going to only use 75% of my CPU cores. If you could do something similar to that on the GPU, that would be helpful for some people that don't want to have the all or nothing approach to running the GPU or not while they're using the console. A lot of times people just need enough GPU left over that the console doesn't stutter while using, you know, basic graphics. They're not running a game, and so they would like to have the GPU running in the background doing science. So I think that would be interesting.
Yes, what I mentioned was to limit the amount of CPU cores, or a fraction of a CPU cores, to be honest, that feeds the GPU as an indirect measure to do something similar. So I'm not aware of anything that would allow you to limit the GPU cores to use by your app. But yeah, I'm sort of out of touch with the whole business right now, to be honest. So I'm not aware of any latest features that might enable that.
Well, someone was talking about over at Folding Home, which is obviously a competitive architecture, that you can limit the CUDA cores. I haven't investigated that yet, but that's interesting.
Okay.
Maybe it's something they added to the API recently, but it'd be interesting to explore that.
Greg?
To my knowledge, the projects that have deployed GPU apps have either done so using CUDA or OpenCL. Have projects explored using newer languages like HIP or OpenACC to use a more unified code base rather than separate CUDA and OpenCL projects?
Not yet.